Hi everyone, my name is Mohammed Lahjiji and I will show you how the MPI Bioinformatics Toolkit works. There are a lot of tools and programs that we use. However, the large majority are hard to install and or to use and therefore remain out of reach for most bench biologists. To alleviate this problem, a number of easy-to-use web services have been developed, including, for example, the MPI Resources Tool and the EMBI Bioinformatics Web Services. The MPI Bioinformatics Toolkit is a simple web-based system that combines the most useful external and internal tools. The toolkit is an open, interactive web service for comprehensive and collaborative protein bioinformatic analysis. It offers a wide array of interconnected, state-of-the-art bioinformatics tools to expert and non-expert alike, developed both externally and internally. The several categories of this tool are search, alignment, sequence analysis, secondary structure, tertiary structure, classification, and utils. Today I will show you all the different kinds of tools for those categories and a couple of examples. So in the search category we have HH-Blitz. HH-Blitz is a remote homology detection tool based on iterative HMM-HMM comparison. In the first step, it converts the input sequence or multiple sequence alignment to a profile HMM, which it then uses to search through profile HMM, but in the UniProt 20 database. Compared to PSI-BLAST, HH-Blitz is twice as sensitive, faster, and produces alignments that are more accurate. For example, I have here a histone H2A Homo sapiens sequence, and I click here to submit it. Here we can see our results, number of hits 250, visualization, the hit list, and the alignments. And there is also an e-value plot, a raw output, and you can even change the parameters. We can even select the ones we want and even forward it to the tools we want to forward it to. Another example of a search toolkit is HH-Spread. HH-Spread is a method for sequence database searching and structure prediction that is as easy to use as a BLAST or PSI-BLAST, and that is at the same time much more sensitive in finding remote homologs. In fact, HH-Spread sensitivity is competitive with the most powerful servers for structure prediction currently available. HH-Blitz and HH-Spread both have homology detection, but the difference between these two is HH-Blitz is a remote homology detection method based on iterative HMM-HMM comparison, and HH-Spread also has a structure prediction by HMM-HMM comparison. So the next category is alignments. There are multiple alignments we already know, like Clustal Omega, MAFT, Muscle, T-Coffee, but there are also others like K-Line and MSA props. K-Line is yet another good quality multiple sequence alignment algorithm. The algorithm follows a strategy that is very similar to the standard progressive methods for sequence alignment, such as pairwise distances, which are calculated firstly but using K-tuple method adapted from Clustal W. The guide tree is constructed using either UPGMA or neighbor joining method, and progressive alignment is completed by following the guide trees. So here we have K-Line and make an example. Those are multiple sequences of different species. Here we can see the cluster alignments, fast alignment, and an alignment viewer. You can also forward it to different kinds of tools, for example MSA props. So MSA props is a well-established state-of-the-art multiple sequence alignment algorithm for protein sequences. It achieves statistically significant accuracy improvement over the existing top-performing aligners, including Clustal W, MAFT, Muscle, Propons, and Probalign. In addition, MSA props is optimized for shared memory CPUs by employing a multi-threaded design. And here we can see our results that we forwarded it to MSA props from Keline. So the next category is sequence analysis. And I'll show you a line-to plot. A line-to plot shows a graphical overview of average hydrophobicity and sidechain volume in a multiple alignment. Hydrophobicity scales are values that define relative hydrophobicity of amino acid residues. The more positive the value, the more hydrophobic the amino acids are located in that region of the protein. These scales are commonly used to predict the transmembrane alpha helices of membrane proteins. So here is an example. This plot shows you the hydrophobicity, and this plot shows you the sidechain volume. If it's here positive, it's hydrophobic, and here you can see how big the volume is of the sidechain. There is also other sequence analysis tools like DeepCoil. DeepCoil is a method for the accurate prediction of coil domains in protein sequences. DeepCoil includes two models for the prediction of canonical and non-canonical coiled coils based on a sequence or a sequence profile. There is also HHREP-ID, and this is a server for de novo repeat detection that is very sensitive in finding proteins with strongly divergent repeats, such as tin barrels and beta propellers. So they also have tools for secondary and tertiary structure, but I won't go further on that. So the next category is classification, and here we have Ancescon. So Ancescon is a package for distance-based phylogenetic inference and reconstruction of ancestral protein sequences that take into account the observed variation of evolutionary rates between positions that more precisely describe the evolution of protein families. So here we have an example of a couple of histone H2A sequences of multiple species, and if you submit it, you will get your tree, and it will look like this. We also have MMSEC2. So MMSEC2, or also known as many against many sequence searching, is a software suite to search and cluster huge protein and nucleotide sequence sets. The software is designed to run on multiple cores and servers and exhibits very good scalability. MMSEC2 can run 10,000 times faster than BLAST. At 100 times its speed, it achieves almost the same sensitivity. It can perform profile searches with the same sensitivity as PSI-BLAST at over 400 times its speed. And at last we have utils that also has some useful tools. Tools like the back translator. It translates an amino acid sequence back into a possible DNA sequence, or format sec that converts H3M to FASTA, or retrieve sec, a tool to retrieve a sequence using a list of accessions IDs. So in conclusion, there are a lot of tools and programs that we can use on this toolkit. You don't have to use different kinds of websites if you want to try some other tools. This MPI toolkit is a simple web-based system that combines the most useful external and internal tools. We can forward this information to different tools so that you can compare different kinds of alignments, and also all your results are saved and you can see them again. For example, if you lost your results or you can't find it anymore, you can find it here without the waiting or process time. And even if you have question about the tool, you can click here so you can get more info about the tool and input and parameters. So this was my MPI Bioinformatics Toolkit presentation, and I hope that everything was clear.